All right, we're going to go back into the same program that I've been working on. It'd be good for you again to create a new separate program so you can keep track of the differences. I'm going to clear this out and dive into edit our struct so that instead of a char array, we do a char pointer. Now, this will mean we're going to have to allocate memory for the name, for every record that we create. So what we could do is, we're not going to be allocating like this. We're going to actually have the record itself be a local variable. And what this means is that if we just declare it like that, then it will have the bytes, the 4 bytes for the integer ID, and it will also have the number of bytes needed for a pointer of type char. But we could assign that memory address to the beginning of a char array. And this is how we could use the name instead, rather than having it automatically local like that. We could go in and yes, the record itself, this variable that we've created, REC, the bytes for the ID and then the memory address, those are local. But then the memory that we would ask for to create the name, that could stay in our program for as long as we need it. And we just attach it to the name for this struct variable temporarily, and we might be able to ship that somewhere else if we need to use that C string somewhere else, and we're going to set it up by asking for that memory with malloc. We could continue to work with that data somewhere else later if we want to. So it's starting to manage things separately like that. So maybe parts of your struct, you could do dynamic allocation, but the entire struct itself would be locally allocated like this. So remember, if it's local, it's in the scope of the function. The ID and then the memory address, the pointer, those will only be available inside the function where I'm declaring this. But then the memory address, malloc, when we go to set that up, record ID, like we did before, 7, record.name. Now this is a pointer, and so we can set it to an address that we're asking for memory with malloc. And here we can do size of char, and then whatever number of elements we need inside of our string. So I know from the name that I've been demonstrating, RUSS, that's 4 characters, but I need one more for that null character on the end. So you got to be a bit careful when you're working with strings like this. You need 5 characters if I want to display a string that has, I need the memory for 5 characters if I want to display 4 characters. Okay. Like before, we could do name and then work with element access if we want to. We'll do Control K and then Control U a few times. We'll go in and set things up like we had before. Which is not the way you really want to work with strings. But again, if you really need to and you're doing something quick and short like this, you could go in and set up the individual characters. Let's take a look at what happens with size of record. And I'm going to get rid of the size of char. We know that's 1 byte now. And then we'll print the ID and the name again like we had before. Now, instead of freeing the record, what we actually need to do is free the name member instead, which is a pointer. So this would deallocate the 5 character bytes that we allocated. Okay, so for you, it probably feels like a lot of the same thing. I still have the pointer access, so I'm gonna have to go back in and use the dot operator instead for our printf statements. Dot, and then dot. So you'll notice that you can't mix the two. If something is a pointer and you want to get members inside of with a struct pointer, you got to use dash right angle bracket for its members. But if it's a struct and it's just regular struct that you declared, then you have to use the dot operator to access the members. So it's one or the other. We've got that execution back there. Here we go. You've got a record structure, says it's 16. So now what I'm curious about, how many bytes does a pointer, so a memory address, take for a pointer of type char? I think that's about maybe the second to last thing that we'll look at. So number of bytes for a memory address of type char is %d \n. We'll do size of, and this might seem kind of strange now, but instead of size char, we do size of char pointer, which is a data type. So if we want the number of bytes for the memory address of that type, we have to give that star at the end as a pointer type. So on my computer, and it could be different on your computer, memory addresses take up 8 bytes. It's probably going to be the case for most pointers that you're working with. The actual memory address, they're probably all going to be around the same size of bytes. Okay, and then you'll notice again, we've got a little bit of padding as well. So the integer ID, that takes up 4 bytes. And then the memory address for char is 8. So it's probably going to want that to pad up just a little bit more. I'm expecting that what the compiler is trying to do, or what's underlying this padding, the reason why they're doing it, is because your operating system, and when you're executing programs on your computer, things can run more efficiently with the data types if you're padding them a little bit so that they fit within locations in memory and take up a certain chunk. And then the compiler takes advantage of that and can set things up to work faster. Okay, we'll go back in and I'm going to pause for a second and I'll come back. All right, what you're looking at here now is a little bit easier to work with if you're thinking about strings and setting them up with a struct like this, where you've got a pointer for dealing with a variable sized sequence of characters in a string. Now, it's nice to do this. It's a lot easier to set it up. but there's a few things to keep in mind. So you'll notice I got rid of the previous setup with individually initializing each character to the value I wanted, which you want to avoid that as much as you can. And I can set the pointer to be equal to a literal like this. And I give my name inside double quotes. But this string as a literal is now set up by the compiler as a constant inside my program. And the memory address will be into the global namespace. And in that initial section of memory, when you go to compile your program and then execute it, the first section of your program is actually setting up your global variables, and any of these literals are part of that. With constants, your program is going to be using them, and so you can get away with assigning the memory address for your pointer to the beginning of that string, the string literal. So it's okay to set it. You can have your pointer refer to it, but keep in mind that you have not allocated memory for the pointer. So the memory for this string right here, it's set up by the compiler, and it's part of my variables, my global constants that are available that the compiler set up for me. It allocated that memory for me for my program. So you don't have to free it at the end if you assign it like this, because you didn't ask for it. It's set up by the compiler. Okay, I think beyond that for now, that's good. And what you would want to be practicing is going in and trying to work with the structures that we've been looking at. Try playing around with the different kinds of things you can do with them, the different kind of data types you can have inside your struct. Practice initializing the values for them. Get comfortable working with pointers. So pointers of structs now, and then pointers inside structs. And not only individual single values that they might manage that you could allocate for, but whole arrays of that type that you could try to manage. That is going to take you a lot of practice. You're going to want to be writing a lot of little small programs, breaking it up, doing as much as you can, a little bit each day. And if you're writing small programs each day, reminding yourself how to do these things, that's really going to pay off for you later. A lot. Okay, I hope you have a lot of fun with it. You get quite a bit of power this way in your programs as far as managing the memory. You definitely want to get as comfortable as you can with managing memory with pointers and using malloc and free.